Hey there! In this section, we're gonna go deep into some inner workings of React once again. So we'll analyze renders in practical terms using this demo application and learn how to optimize wasted renders and performance in general using some more advanced React tools. This way, you'll be able to understand React apps even better and make them as fast and snappy as possible. We'll also go even deeper into the useEffect hook because there's still a few more things that we need to learn. So this is another truly advanced section and one that I'm really excited to share with you. So get ready to take a lot of notes and really take your React skills and understanding to the next level one more time. We're gonna start this section by getting a quick overview of what can actually be optimized in React applications and how we can do it. So there are three main areas that we can focus on when we need to optimize performance of React apps. First, we can try to prevent wasted renders. Second, we can improve the overall app speed and responsiveness to make sure that the app is 100% fluid and without delays. And third, we can reduce the bundle size. So let's quickly look at some built-in React tools for each of these areas. So in order to prevent wasted renders, we can memoize components with memo, or we can memoize objects and functions with useMemo and useCallback hooks. And of course, you don't know what any of this means at this point, but we'll get to it over the next few lectures. We can also use a technique where we pass elements into other elements as children or as a normal prop in order to prevent them from being re-rendered. Now, to improve the perceived app speed, we can again use the useMemo and useCallback hooks, and we can also use the modern useTransition hook. And again, more about these later. Finally, we can reduce the bundle size simply by using fewer third-party packages in our code base, and we can also implement code splitting and lazy loading. Now, there is no need to use all these tools and techniques all the time. So the main goal of this section is to basically just give you access to these tools so that you can have them in your toolbox whenever a situation calls for one of them. And throughout this section, you will learn exactly when that is. So in which situations you need each of these tools. Also, keep in mind that this list of tools and techniques is by no means exhaustive. So there are many other optimization best practices that I already told you about before and that you are already using. For example, not defining components inside other components. And so I didn't include all of these in this list. So these are mainly tools that we will talk about in this or in future sections. Now, the first part of this section is going to be about optimizing wasted renders. However, to understand what wasted renders actually are, we first need to review when exactly a component instance gets re-rendered. So this will serve as a nice reminder of how rendering works in practice. So in React, a component instance only gets re-rendered in three different situations. First, when the component state changes. Second, a component instance gets re-rendered whenever there's a change in a context that the component is subscribed to. And this is exactly what we've learned in the previous section. And finally, as we learned in the section on how React works behind the scenes, whenever a component re-renders, all its child components will automatically be re-rendered as well. And so the third reason for a component to re-render is a parent component re-rendering. But now you might be wondering, what about prop changes? Doesn't updating props also re-render a component? Well, actually, that's technically not the case. So that's a common misconception, And actually, even I told you this at the beginning of the course, but it was only because you didn't know yet how rendering works. Because it is true that it does look as if components re-render when their props change. But what actually happens is that props only change when the parent re-renders. But when the parent re-renders, the children who receives the prop will re-render anyway. And so the real reason why a component re-renders when props change is that the parent has re-rendered. Okay, but anyway, it's important to also remember that rendering a component does not mean that the DOM actually gets updated, right? So all that rendering means is that the component function gets called and that React will create a new virtual DOM and do all the diffing and reconciliation that we have already talked about before. And this can be an expensive and wasteful operation, which brings us to an important topic of this video: wasted renders. So a wasted render is basically a render that didn't produce any change in the DOM. So it's a waste because all the diffing calculations still had to be done, but it didn't result in any new DOM. And so therefore, all the calculations were for nothing. Now, most of the time, this is actually no problem at all, because React is very fast. However, it can become a problem when re-renders happen way too frequently, or when the component is very slow in rendering. And so this can then make the application feel laggy and unresponsive. For example, not updating the UI fast enough after the user performs a certain action. So we want to avoid situations like that at all costs. So that's basically what we're going to be dealing with in the next couple of videos. We have used the React developer tools all the time throughout this course, but actually we have only used half of them until now. And so let's now meet the other half, which is the profiler. So for the first half of this section, let's actually bring back our atomic block project. So let's open that up in VS Code. And so I'm here in the app.js file, so the latest file that we wrote. So let's close that and let's npm start it. Okay, there it is. And so let's actually make this window a bit bigger so that we can actually see our developer tools. So, as I mentioned in the beginning, we have used the components React developer tool a lot, but we have never used the other part. So this profiler right here. So with the profiler, we can basically analyze renders and re-renders. So we can see which components have rendered, see why they rendered, and also how long each render took. Now in practice, we use the profiler by clicking here on this record button, and then we update some state. But before we go do that, let's change the settings here, and coming to this last tab, which says profiler, and then here we want to activate the setting which says that it should record why each component rendered while it was profiling. And so basically this will give us one of the three reasons that we talked about in the previous lecture of why each component has re-rendered. So whether it was a state update, a context update, or a parent re-rendering. All right. Now, if you reload the page, then you will have to reset that setting actually, which is a bit annoying. But anyway, now I will start recording and then I will update the state of the page by typing in here. So let's type 3 times so we see how that actually looks like in the profiler. And then we click there to stop the recording. And then here is our flame graph. So we can see the result in the flame graph and here in this ranked graph. So starting with the flame graph, this is basically just another way of representing the component tree. So as the parent, we have app, then we have our provider, and inside the provider we have indeed the header and the main, which in turn contain all of these components. So just like we have here. Now what's special about this is that some components are actually colored and some are gray. So the gray components are the ones that did actually not render while the application re-rendered. So main, posts, and app did not re-render, but all these others did. And the more yellow the color is, the longer it took to re-render. So the post provider, we can see, took the longest. Now in order to rank them, we can, as the name says, use the ranked tab here. And so here we can then very clearly see, for example, that some of these components were really fast to render, while this one here took a bit longer. And even though that's less than a millisecond, which is really nothing. Now, thanks to the setting that we activated in the beginning, we can also see why each of the components re-rendered. So here, for example, we can see that the post provider re-rendered because hook 2 changed. And so the hook 2 is simply the useState hook, which is storing this search query here. So then here, the provider usually doesn't say. And then here, the header re-rendered because context changed. So let's check that out actually here. So indeed, the header is consuming the context, and so therefore it changed as we updated the state here in the context, right? And the results and this form and the list, all of them are consuming the context. And so therefore, they then also updated as the component was updated, while the main and the post components are not consuming the context, and so they did not re-render. So this is how we can basically analyze this flame graph. Now up here, we have the different commits, how they are called. Or in other words, each of them here is one re-render. So I think that's easier to understand. And so since we did 3 times the same thing here, we should expect them to look basically the same. Now the timings have changed here for some reason, but the components that have actually rendered and not rendered are exactly the same. All right, and now let's try something else. So for that we can clear and then record again. And now let's simply click here on this fake dark mode button. So just one re-render. And so then here we only get this one column. And so this time, as we can see here, every single component has re-rendered, which makes sense because the state update actually happened right here in the main parent component. So here in the app component. That's why here it says that hook number 1 changed, which is this one. And then we can see here, for example, this one did render because the context changes or changed, which actually seems a bit strange, but we will come back to this later. So we will understand why React is saying this. So all the components that are consuming the state actually are telling us that they have re-rendered because the context has changed. While these two, which before were gray, are now also colored, and these two did re-render because the parent component rendered. And so again, when the parent component of the application, so the component at the top of the component tree, re-renders, then all the child components will re-render as well. Okay, let's just put this back, let's delete, and let's try another one. So 1, 2, 3, and 4. So let's see. And indeed, here we have our 4 state updates, or 4 re-renders. So in the first 3, we can see that only the form at post re-rendered. And so that is, let's see where that is. So that is because these are local pieces of state. And also this component has no child components. And so then only this one re-rendered the 3 times that we wrote something there. But then here we have a similar picture to what we had before. So not all the components have re-rendered here, like the footer and the main component did not re-render as a result of adding a new post. Okay, So feel free to play around with this new tool here as much as you'd like, as this will be pretty important throughout this section and also later once you start building bigger and more heavy applications which might require some performance optimization. So we will use this tool throughout this section, and so make sure that you play around again with this a bit more, and then let's move on to the next lecture to talk about our first small optimization trick. Let's now learn about a simple performance optimization technique which leverages the children prop in order to prevent some components from re-rendering. Now, this isn't the most used technique out there, but it gives us actually surprising insights into how React works internally. And so that's why I wanted to share this with you. Also, not many people know about that this is how React works, and so this makes this even more interesting. Now, in this lecture, I want to bring in this test component inside the test.js file, which was part of this project here in the beginning. So this test component implements a very simple counter. So it has a button to increase the count, and it also displays that count. And then the count also contains this slow component. And so what this slow component does is to basically create 100,000 words and place them into an array. And it then renders this 100,000 element long array here in our user interface. And so let's now include that here below our list just to see what's going to happen. So this is basically an experiment with which I will show you that optimization technique that I was talking about. So let's include that. And it's not list, of course, it is test. So let's include the test here inside the list. And then let's see what we get here. And by the way, if your application is taking way too long to load, you can always quit the application and restart it, or you can try to reduce the number of elements right here. So maybe 100,000 is a bit too much for your case. And yeah, so if that doesn't work for you, then just change the number of words there. So you see we have like this infinite amount of words now. And the idea here is that this simulates a very slow component. And so let's see what happens as we click here. So I click, and then it takes like half a second until the button actually updates. So let me do that again. So maybe you can hear my click. Let me do that just one more time. And probably for you, it also takes this long. And so the reason for that is right here. So basically here, each time we click on the button, this state updates. And so this entire component needs to get re-rendered. And so therefore, this slow component is also re-rendered each time that we click the button, even though this actually isn't really dependent on the state. So the slow component does not need the state at all, but still it is being re-rendered simply because it is inside this test component. So if you ever find yourself in a situation like this, where you have one kind of slow component inside another one, which updates this one without it needing it, this is where you can then use this optimization technique. So what I'm going to do is to take the counter functionality out. So counter like this. And let me just copy all of it. But here not the slow component. But instead, here I will now render the children prop, because we will now pass this slow component into the counter as children. So let me comment all of this here out. And let's return a new div here with the same h1, just so it all looks the same. And then here, comes the counter. So just like this, and then this is where we place the slow component. And so this actually looks exactly the same. So the component tree will also be exactly the same, where we see here that basically we still have the H1, the button, and then in the UI, the slow component. So this entire list here. However, it will now work in a completely different way. So let's see what happens now when I click here. And you see that it is instant, right? So this means that actually probably this list here is no longer being re-rendered. And we can actually prove that by clicking here now on the Start Profiling button, then updating the state by clicking on the button, and then stopping it here. So here is of course the counter, so the counter component needed to update, but then we see that the slow component did not render. So why is that, even though basically our JSX is very similar? So the structure of the output is very similar, and indeed it does look exactly the same as it looked like here in the UI previously, right? So the only thing that we changed is that we no longer have slow component here like this, but instead we pass it in as a children. And so then here we display it as a children. So why does this work this way? So why is suddenly React no longer re-rendering this component? Well, again, this element, the slow component, has this time been passed in as a children prop. And so what this means is that this component here was actually already created before the counter component re-rendered. And so therefore, there's no way in which this component could have been affected by the state change in the counter, right? So again, as React sees this piece of JSX here, it will basically immediately create the slow component right here and then pass it into the counter. So all while rendering. And then as we click here on this button, the counter is of course re-rendered, but this component again has already been pressed in as a prop. So it has already been created before, and so it cannot be affected by that state update. It already exists. And so that is the reason why React then bails out of re-rendering this children component, because nothing could have changed inside of the slow component. So React is smart enough like this and can therefore decide not to re-render this. Okay, so hopefully this made sense and that you found it as interesting as I did. So when I first found out about this not too long ago, I was quite surprised that React works this way. And so you might actually find situations like this in the real world in your own code. And so in that case, just be aware that this trick exists. So all you have to do is to refactor your code a little bit so that you can pass the slow component, whatever it is named in your case, as a prop. And it could also be some other prop. So you can call this like show this or whatever, and then you pass the slow component in there like this. So that would work exactly the same, because then also React would already have been created, this component here, before anything ever happens inside the counter. All right, and this is really all I wanted to do with this test component. So let's now get our application back to normal, but this actually has another very interesting implication in the way that our context works right now. So let me again start profiling here and just search once and then stop this. And so here we see again that these two components have not been re-rendered. But why is that? Why have they not been re-rendered? I mean, there has been a state update inside the post provider component, right? So this post provider right here is actually just a regular component. And so when we searched here, we updated this state, which then re-rendered this component. And so therefore, all the child components should have re-rendered as well, right? So all of these should have re-rendered as well if we follow that logic, because again, all of them are child components. However, we see again that these two did not re-render. And the reason for that is exactly the same that we saw earlier with the test and the slow component. So the reason again is that all of these child components here were actually passed into the post provider as children. And so we are in the exact same situation as before, where all these child components were already created before they were passed here into this component. And so then React once again bails out of re-rendering all of them because they couldn't have possibly been affected by any state change, unless, of course, they do actually consume the context itself. So that's the case for this one. Well, now we cannot see that because I reloaded the page in the meantime. So I would need to turn this setting back on, but this only works for the next time. Well, let's just do that now again. All right. So yeah, now we can see that. Let's make this a bit bigger. And so this one here did re-render again because the state has updated. And then this one has changed only because the context has changed, not because the parent component has re-rendered. So the same here and the same here. While again, these ones were not re-rendered because they were passed in as children, and so they were already created before the post provider was even created, and so they could not have been affected by any state change in there. Okay, so I hope that made sense and that you keep this technique in the back of your mind, even though it is probably not used all the time. But it's very, very interesting. And I think this puts you in the top 1% of React developers when it comes to knowing about this kind of stuff. Over the next few lectures, we're gonna add 3 more React tools to your toolbox: the memo function and the useMemo and useCallback hooks. Now, the fundamental concept behind these 3 tools is memoization. So that's not memorization, but really memoization. So memoization is an optimization technique that executes a pure function one time, so let's say function A, and then it stores the result in memory, so in a cache. Then, if we later try to execute the same function again with the same inputs, it will simply return the result that was previously stored in the cache. So the function will not be executed again. And that makes a lot of sense, right? So if the arguments are exactly the same as before, it means that in a pure function, the output will be the same. Therefore, it makes no sense to execute the entire code again if we can just read the cached result. On the other hand, if the inputs are different, then of course the function will simply be executed again. So that's the concept of memoization. But you might be wondering what this has to do with React. Well, in React, we can use this technique to optimize our applications. So we can use the memo function to memoize components with exactly this principle, and we can use the useMemo and useCallback hooks to memoize objects and functions. And doing so will help us prevent wasted renders and improve the overall application speed. Okay, so now that we understand what memoization is, in this lecture, it's time to look at how to memoize components using the memo function. So, React contains a memo function, and we can use this function to create a component that will not re-render when its parent re-renders, as long as the past props stay the same between renders. Or, in other words, we use memo to create a memoized component. And if we think about it, this is exactly the optimization technique that I explained in the previous slide. So the function inputs are props, and calling the function multiple times is equivalent to re-rendering in React. And therefore, memoizing a React component means to not re-render it if props stay the same across renders. And just like with memoizing regular functions, this makes a lot of sense, because why re-render the component if the input data hasn't changed at all? Now, the regular behavior in React without using memo is of course that whenever a component re-renders, the child component re-renders as well. On the other hand, if we memoize the child component, it will not re-render as long as the props are the same as in the previous render. Now, of course, if the props do change, then the child component will need to re-render as well in order to reflect this new data that it received. Now, it's super important to keep in mind that memoizing a component really only affects props. This means that a memoized component will still re-render whenever its own state changes, or whenever there is a change in a context that the component is subscribed to. Because in these two situations, the component basically has new data that it needs to show in the UI. And so then it will always re-render, no matter if it's been memoized or not. So, from what we just learned, memo sounds great, right? Now, does that mean that we should go ahead and memo all our components? Well, the answer is no, not at all. So memo is only useful when we're dealing with a heavy component. So a component that creates a visible lag or a delay when it's rendered. Also, in order for memo to actually make sense, the component should render quite frequently, and it should do so with the same props. And let's analyze why that is. So first, if the props are usually different between re-renders, memo has no effect anyway, and then there's absolutely no need to use it. And second, we learned in the first lecture of the section that wasted renders are only a problem when the re-rendering happens too frequently or when the component is slow in rendering. Therefore, if the component only re-renders from time to time, or if the component is lightweight and fast anyway, then memoizing brings no benefit at all. Okay, and now it's time to see this in action in the next lecture. Let's now check out a practical example of memoizing a component. So here we are still in the Atomic Block project, but for these next few lectures, we actually need the original app.js file from the starter files. So let's move there. So grabbing again app.js, and let's paste it right here in the project folder, and then I'm going to rename it to app-memo, and then let's place it into the source folder. Okay, so let's open that one up here, and then also in index.js, we now need to link that file. So we now want to import the app from app-memo. And we need this component right here, so the original one, because here we don't have any context yet, and instead we are passing some props around, which is what we need for these next few lectures. Now here in the archive, let's actually remove this prop, and let's just add one here called show and set it to true. And then let's come down here to the archive and accept that. So in this lecture, we will actually work with this archive component. Then here, let's make this show archive dependent on this show prop. And then we need to remove this button right here. So this button was using the onAddPost function that we passed in as a prop earlier, but now we no longer have that prop. All right. Now we never really looked at this component here in the beginning, so let's just quickly understand what it does. So basically it creates these 10,000 random posts in the very beginning and stores them into the posts state. Now by default, all these 10,000 posts are not actually shown because we have the show archive state set to false. At least that's what the incoming prop is. Now here for some reason it is open. Let's just reload that. And well, maybe I set it to true up there. Yeah, here I want false actually. So that by default, that huge list of posts is not rendered. So here we have some conditional rendering based on that state. But as soon as I click here, it will actually open this list of posts. Now let me actually increase the number here a bit to 30,000. But if your computer is maybe a bit slower, then you can leave it or maybe even reduce it. So otherwise, your computer or your browser might crash. So let's see again that when I click on this button here, it actually takes a long time for the entire thing to render. So that's probably like almost a second here. Now the problem is not that it takes a long time to render this list here, because that's just completely unavoidable. So it's so many items that of course it will take some time. Now the problem is that this will slow down the entire page. So watch what happens when I type something here into the search bar. So notice how this created a big lag. So let's show again. So as I type, it takes like half a second until that letter actually appears there. And so let's now also inspect this using the profiler. So let me actually reload again so that the archive is closed. And so then we will do a before and after. So we are now profiling. So now I type and it is really fast. But now let's open the archive. So we have a second render here or re-render. And then let's type something here. And now it is really slow. But just watch how slow that actually is. So here again, we have the 3 re-renders that happened. And by the size of the bars, we can already see that this last one, so the second letter, was really slow. So here the first keystroke for the H right there was just normal. So everything took like 1 millisecond or 3 milliseconds. So something really, really fast. But then watch how long it took to render the archive. So it took 131 milliseconds. And that's just the rendering itself. So just calling the function. Then painting the whole thing to the DOM took even longer than that. So probably like 1 entire second. But anyway, what matters to us is here this second keystroke. So when I wrote the A there. So notice here how the archive re-rendered when I typed something here. And so the reason for that is of course that the archive is a child component of the app component, which is where that state actually lives. And so if we update the state in the app component, that will then, as we already know, trigger a re-render in all the child components. And so that includes the archive. And notice how it took even so long that all the other components don't even have space to appear here in this flame graph. But if we take a look at the ranked chart, then we see all the other components. And so here again, we can see how fast all of them are in comparison to the archive. All right. And so again, this is the real problem that we have, which is that typing here now makes the entire application really, really slow because it always needs to re-render this really slow component. And so this archive component is a perfect candidate for memoization. So let's do this now here in practice. So the way we do that is to just wrap the entire component function into React's memo function. So we just call memo, which is then imported from React just like useState or useEffect. So notice here that it simply imports memo from React. So it's just another function that comes with React. And then we just wrap everything into that function call. So basically we call memo with the component as an argument, and then this function will return a brand new component. And so then we need to store that component also somewhere. And so we create a variable which we call, again, archive. And so now our archive component is all of this here. So the memoized version of the original archive. And here we could probably even remove the duplicate name and make this an anonymous function, but I guess it's best like this. So just leave the name here as well. And yeah, with this, we have actually successfully memoized the archive component. And remember that this was a great candidate for memoization because the archive component is very heavy, it re-renders very often, and it does so with the same props. So the only prop that it has is this show prop, which is always false. And so, yeah, again, this is a great candidate. And so let's now do exactly the same profiling that we did before in order to show if it improved our situation. So let's start here. So that was fast because the archive is still closed. Let's open that up. And this, of course, takes exactly the same time as before, which makes sense because, as we just learned, memoizing a component has nothing to do with updating state. So memoizing only affects the props. So that list still has to be rendered, and so that still takes time. But what should have changed is the time that it takes to now re-render as we type something else here. So let's try that. And we can immediately see that this was really fast. And now our profiler should prove that. And indeed, now here in the second time that we typed something, it is really fast again. So here, even the first time that there was a keystroke, we can see that the archive did not render. So here it is showing us that this component is memoized even. And so again, it did not render, which is because the prop that it received was still the same as before. So the prop that it received is show, which is always true. And so then this component didn't have to re-render as the parent re-rendered. And again, here the same thing when the component was already opened. And so with this, with the simple memoization, just made our component really fast and snappy again. So we can type all we want, even with that archive open, because it will not re-render on every keystroke. Or also here, each time that we click on this button, for example, which before would also be really slow, because clicking here also renders the app component. Great. So this is why and how we memoize a component in React. But now let's do something that will break this memoization so that I can then introduce the next lecture so that we can then solve that problem in the future. So let's say that now, instead of passing in this prop right here, I instead want to pass in an object. So let's create an object here called archive options. And then let's say show is false. And the title, let's say post archive in addition to main posts. And now here, instead of the show prop, I'm going to pass in that object. So archive options, set it to archive options. And now let's get that here. And now here we use archive options dot show, and here we use archive options dot title. Give it a save, then let's reload here, and then let's run exactly the same experiment as before. So just typing something here, then opening here the archive, which as always takes some time. And now as I type, notice how it will be back to taking a long time. So you saw that. And indeed, we are now back to basically re-rendering this component, even though it is memoized and even though it looks as though our prop hasn't changed. So the archive options that we received still looks the same as before. It's just this object right here. But still, now our archive component was re-rendered again. So let's now find out why this is and how we can fix that in the next lecture. In the last lecture, we found a situation where the memo function didn't actually work as expected. And so let's now understand why that happens and learn about the solution. And let's start from what we already know. So we know that in React, whenever a component instance re-renders, everything in there is recreated. So all values are always created again, and that includes objects and functions that are defined within the component. So a new render gets new functions and new objects, even if they are the exact same ones as before. We also know that in JavaScript, two objects or functions that look the same, so that are exactly the same code, are actually different, unique objects. And the classic example here is that an empty object is different from another empty object. Now, from these two pieces of information, we can understand that if we pass a function or an object to a child component as a prop, that child component will always see them as new props whenever there is a re-render. And if props are different between re-renders, then memo will simply not work. So it will not do its job. So in summary, if we memoize a component, but then give it objects or functions as props, the component will always re-render anyway, because it will always see these props as new props, even when they actually look exactly the same. Okay, but there must be some kind of solution, right? Well, of course there is. So we can make objects and functions stable. So we can actually preserve them between renders by memoizing them as well. And to do that, React gives us two more hooks: useMemo and useCallback. So we can use useMemo to memoize any value that we want to preserve between renders, and useCallback to memoize functions between renders. And I will just use the word values for everything here, because useCallback is actually just a special case of useMemo. But anyway, what does memoization of values actually look like? Well, the idea is similar to the memoization that we just talked about before. So whatever value that we pass into useMemo or useCallback will basically be stored in memory. And that cached value will then be returned in future re-renders. So it will be preserved across renders as long as the inputs stay the same. Now, in the case of useMemo and useCallback, these inputs that I just mentioned are called dependencies. So just like the useEffect hook, useMemo and useCallback also have a dependency array. And this is how it works. Whenever one of the dependencies change, the value will no longer be returned from the cache, but will instead be recreated. So this is very similar to the memo function, where a component gets recreated whenever the props change. It's just a different thing that we're memoizing here and a different way of specifying the inputs, but the idea is the same. And this will all become quite clear once we start writing the code. But for now, let's visualize what we just learned. So the regular behavior in React when we do not memoize a certain value is, of course, that a new value is created whenever the component re-renders. On the other hand, when we do memoize the value, then no new value is created on re-render and the cached value is returned instead. And so, like this, the value will stay exactly the same. So it will be stable across renders. However, this is only true if the dependencies that we specify in the dependency array don't change. If they do change, then a new value is actually created as if the memoization has never happened. Okay, now this all sounds great, but when do we actually need this? Well, remember that we started this lecture by saying that we need to make objects or functions stable in order to actually make the memo function work. In other words, if props are objects or functions, we need to memoize these props in order to prevent wasted renders. So that's what the very first slide of the lecture was all about, right? And this use case is probably the biggest use case for useMemo and useCallback, and it made it very easy to understand why there is a need for these hooks. However, there are actually two additional use cases. So the second use case is to avoid expensive recalculations on every render. For example, you might have a derived state that is calculated from an array of 100,000 items. Now, if your component re-renders all the time, then React needs to do this expensive calculation over and over again each time there is a render. And so, to fix this, you can simply preserve the result of that calculation across renders using useMemo. And so then, React doesn't have to calculate the same thing time and time again. Finally, another use case is memoizing values that are used in the dependency array of other hooks, for example, in order to avoid infinite useEffect loops. Now, just like with the memo function, it's important to not overuse these hooks. So you should probably only use them for one of these three use cases and not start memoizing every single object and function everywhere. But anyway, with all this being said, it's time to finally try this out with code. Let's now use the useMemo hook to fix that problem that we created ourselves with the archive component earlier. So remember how earlier we created this object right here and then passed that as a prop into the archive component. Now the problem with this is that doing so actually breaks the memoization that we created for the archive component. So we saw that here in the profiler also earlier, where we saw that after the archive is open, then it again takes a long time for us to see the results of typing here. So we can also see that in action because the application is really laggy and unresponsive as we type into this field. So as we just learned in the previous lecture, the reason for that is that this object right here is recreated over and over again each time that the app component re-renders. And so basically then the prop that the archive receives will always be different. And so then of course memo doesn't do anything. So what we need to do is to make this object here stable over time. And so that's where the useMemo hook comes into play. So let's use that hook here. So useMemo, which again needs to be imported from React. So let's call that. But now it is actually not as simple as just wrapping this entire object into useMemo. So that's not how it works. Instead, useMemo actually takes in a callback function which will be called on the initial render. So very similar to the useState hook. So in this case, all we need is an arrow function which we want to return our object. So return this object right here. All right, so this callback function here is basically the work that should be performed on the initial render and which result should be then stored in the cache. So should be stored in memory so that React can remember it across re-renders. Now in this case, all we're doing is to return an object here, but there could be also some more intensive calculation going on, which is the reason why useMemo takes in a function and not just a value. All right, so again, whatever we return from this function will be saved in the cache. And so then remember, we also need to pass in the dependency array, which will basically determine when this whole calculation here is executed again. So just like the useEffect hook, right? So by specifying an empty dependency array here, that means that this value will only be computed once in the beginning and will then never change. So it will never be recomputed. And so this should actually already have fixed it. So let's re-render here, clear that. And now our archive is closed. And of course, we want to profile this again. So this is fast as always. Then we just open this again, which takes its time. And now we will see if that memoing has worked. And it was really fast, so it looks like it did. And indeed, the archive was not rendered in the beginning, and also not as it was already opened. Great. So we fixed the problem, and our memoized component is now back to working. So we have now this stable value here over time, which will simply be taken from the cache as long as the dependencies don't change. And speaking of the dependencies again, right now we don't have any, but actually let's create some. Or at least one. So here I now want to change the title to use a stateful variable. So to use the posts. So now here I want to say post archive in addition to, and then the number of the main posts. So that is posts dot length. So it's not the filtered posts. So it's not this value right here, but really the amount of posts that exist. And so now we need to specify that value here in the dependency array, because otherwise this object here will never be recomputed. And so let me first show you that actually this is how it works. So right now it says here, in addition to 30 main posts. So let's add another one and watch what happens. So here it now says that 31 posts were found, but down here we still say 30. And so that's because React is still reading this object from the cache, which it didn't update, because we didn't place this post variable into the dependency array. And so therefore, this function here was never called again. And so then React is still using the stale value of this post state. So here we are again in the presence of stale state and of a stale closure. So a stale closure because this function here was created initially, and from there on, it now remembers all the variables that are referenced inside of it as they were at the time that the function was created. So that's what a closure is, and it is a stale closure because it never run again. And so it is still remembering the old values. So that's one of the weird things about React, which is very confusing for beginners. But that's why I'm talking about this time and time again, because this is the kind of stuff that you really need in order to master React. But anyway, let's now then place the entire thing here into the dependency array. So not just posts, but really posts.length, which is a lot better because post is an object and this is a primitive. So it's always best to have primitives in the dependency array. And we will learn more about that even later in this section. But anyway, you can see that it actually already updated there to 31. But let's change this again, or test this again. So 31 up there, and beautiful. Now it updated down here as well. Now the consequence of this is that whenever this archive is open, it will then take a long time to re-render the application when we add a new post. Right? So let's check that. And now I will just call something very short so that we don't get all those re-renders in the profiler. And then notice how that took some time. And so indeed, we can see that here in this last state update, where now the archive, of course, still had to re-render, because now, this time, our object here actually has been recreated. So we added a new post, and therefore posts.length was changed. And so then this object here became a new object, making it so that the prop changed, which in turn triggered the archive to be re-rendered as a result, even though it is memoized. Okay, so hopefully all of this made sense. And later on, we will actually see another use case of the useMemo hook. But for now, let's move on to the useCallback hook. After useMemo, now it's time to quickly also use useCallback. And as we already know, the goal of the useCallback hook is to memoize functions. And so to test this, let's now pass in a function again into the archive component. So let's now bring back the onAddPost prop that we had here initially, but that we removed. So onAddPost should be handle addPost like this. And then let's grab this prop and receive that here in our memoized archive component. And then we can reactivate this button right here. And so then if we reload this, and here let's clear. So now we get this button here that we can click, and that will then, as you see here, add it to this list. And so now we have 31 posts, and if we add another one, then we have 32, and so on. So that's the goal of that function. Now the problem with that is that now we are back to having the same issue as before. So let's again, well, first let's close this actually, so that we have the before and after. And actually let's this time test with this button here. So this fake dark mode button also changes state on the app component. And so it will also re-render the archive. So let's click that. Then let's open the list. And then let's set the state again. And so maybe you saw that it took a long time. And yeah, so we are back again to having our memoized component re-render, even though it is memoized. So we had the same problem earlier in the previous lecture because of this prop here, which is an object, but we solved that by memoizing it using useMemo. And so now we have the same problem, but with a function. So now this function here is causing us the same problem, and the solution is the same. So the solution is also to now memoize this function. And so let's do that by using the useCallback hook. Make sure that it gets imported from React. And then here again, the dependency array, which is empty. And so this will then return the memoized function, which we can then store into a regular const variable. Okay, and that's actually it. So you see that useMemo and useCallback are pretty similar, but the difference is that useCallback will not immediately call this function, but will instead simply memoize this function, while here useMemo will basically simply memoize the result of calling this callback. So that's the main difference. useMemo just stores a result, so like a value, which is the result of this callback, while here in useCallback, only the function itself is actually memoized. All right, and so this should already be enough to solve our problem. So let's clear that. Let's do exactly the same thing again. So this was fast. And let's see. And this also seemed pretty fast. And our profiler confirms that result. So we are back to not re-rendering the archive component. So memoization is back to working indeed. And we also noticed a very noticeable difference in the speed and snappiness of our application. Now, some teams, for some reason, choose to wrap each and every function and value into a useCallback or a useMemo. But that actually makes very little sense, and it might even do more harm than good in most of these cases. So using one of these functions here, like useCallback, actually has a cost as well. So React needs to run this function and needs to store the function in memory. And so that only makes sense if we actually see some improvement here in our application. For example, this component right here, there's no need to wrap it into a useCallback, because this is not creating any problems for us anywhere in the application. And so it's best to just find some slow components that do actually have a visible bad performance, and then using the tools that we just learned about to only optimize those. Okay, but we already talked about that before when I first introduced these two hooks, where I showed you the 3 big use cases of these two hooks. Now, one thing that I wanted to mention, which I didn't mention in that lecture, is that in the future, the need to doing any of this stuff, like any of the memoization, might actually disappear completely, because the React team is currently researching a compiler that would basically automatically memoize all the values that need memoization behind the scenes. But still, even with that on the horizon, it is still very good to know about all of this stuff. First, because that compiler might actually never happen, and second, because you will still see these hooks here all the time in a bit older code bases. So you should definitely know about how this works, and of course also know how to use the profiler to find some low-performing components, and also all the other techniques that we're going to talk about throughout this section. And finally, I want to just quickly finish with a small experiment. So let's pass in another function into our archive component, but this time a special one. So let's say here this setIsDark function. And I say special because this is the function that is returned from useState. And so let's pass that as a prop just to see what happens. Already passed that. So set is fake dark. And just like this. So we are again now passing a callback function here as a prop, which we did not memoize. So let's see if that will then again slow down our component. So let's record. Let's do it once. So the fast version. And again. But it did seem pretty fast. Maybe you noticed that as well. And we see that actually the archive did not re-render. So the memoization is indeed still working. So even though we did not memoize, set is fake dark. So why do you think that is? Well, basically React guarantees that the setter functions of the useState hook always have a stable identity, which means that they will not change on renders. So we can basically think of these state setter functions as being automatically memoized. And in fact, this is also the reason why it's completely okay to omit them from the dependency arrays of all these hooks. So from useEffect, useCallback, and useMemo. So in fact, we do have a state setter function right here. So we're using a function here inside this use callback, but still React or ESLint is not complaining that we're not using that function here in the dependency array. While if we were, for example, to use, for example, just the posts, then here React would complain. So here we would then have to place the posts inside the dependency array so that whenever the posts change, React could then update the function here in the cache. So could basically cache the new version of this function with these new variables. But again, with the state setter functions, that's not necessary. And that's true for all the dependency arrays in all the 3 hooks that have them. Okay, now that's actually all I had to tell you about these 3 important tools. So memo, and use callback. Now, as I mentioned earlier, you're not going to use these tools all the time when you work with your own React applications, but you still need to have them in your toolbox. And I know that they are really quite confusing in the beginning. So it took me actually a long time to understand when I should use each of them. But that's why I tried to give you these demonstrations, to show you the use cases in the theory lecture, and then all you can do now is to really practice these functions, maybe in your own examples, or in the future in your own applications as well as the need arises. Okay, and actually next up we will use some of these tools a bit more to optimize context. Let's now take a look at a few strategies that we can use in order to prevent wasted renders related to the context API. And for that, let's actually come back to our app.js, which is the one where we already use our context. So notice how here we don't pass around any props anymore, and we use our custom hook that is coming from our context. So we no longer need this. We also need this file, of course. And now in the index, let's go back to importing app from the app file. Okay, and now let's see what we can do here to optimize this a little bit. But before we go do that, it's actually very important to understand that you only need to optimize your context in case that 3 things are true at the same time. So first of all, the state in the context needs to change all the time. Second, the context has many consumers. And third, and probably most importantly, the app is actually slow and laggy. So only if all of these are true, it is time to optimize context. Now, the actual optimization of your context can be quite confusing because it's going to depend a lot on how you build your application and how you set up your context, and also what exactly you pass into the context. And so I cannot give you a clear recipe here, but I will just try to show you a few different things here. So first of all, remember that we are already doing that optimization where we pass the children into the component. So what we render here are simply the children that we pass in. So these components right here. And so remember from earlier that this makes it so that these children are not all automatically re-rendered because they were already created before they were actually passed into this provider component. So let's just see that in action here once again. So as I record now, let's type something, let's stop. And so here we see again that these 2 components and also the footer are not automatically re-rendered. And so this alone is already a good optimization technique. So if we just had basically this right here in the app.js, so basically what we did earlier in v1, so let's see. Yeah, so remember how earlier this is what we had. So we had these children here directly inside the post context provider. And then all of these children right here would also automatically have been re-rendered as we changed the state inside that context. So we already have that optimization going on, but if for some reason you are not doing that, then you should memo all of the direct children of that context. So basically what we did earlier, which is to wrap this component and the main and the footer all into a memo. So memoizing those components so that they don't automatically re-render once we update the state in the context. Okay. So that's one of the guidelines that I can give you. So doing either this technique with the children or to memoize the direct descendants of the context. Now, next up, let's try to see what happens when we update the state in the application above our provider. So for example, this one right here. So this state lives in the app, but since this post provider is a children of that, it will then also automatically re-render. And so let's see what happens then. And for that, let's also turn on again this setting here. So recording why each component rendered. Then let's clean this. Let's clean this as well. And then let's just start recording. And now what I'm going to do again is to change the state in a component that is above our custom provider component. So let's see what happens. And indeed, now all the components did re-render. However, they did re-render for a different reason that we might think. So of course, app itself was re-rendered because the state changed, but then, for example, this one here, so the main was re-rendered because the parent re-rendered. So that makes a lot of sense, right? The same here, and then we would expect the same to also happen in the list. However, the list did actually re-render because the context changed. Well, that's strange, right? Because this state right here with the dark mode actually has nothing to do with context. But still, all the components that consume the context did now re-render because of context. So the same thing here, and the same thing in the archive as well. And just keep in mind that we are now working with a different app where we no longer have the archive memoized. Remember? So we memoized the archive earlier, but now we are back in the other app.js file. But anyway, we would have thought that all of these components re-rendered because their parent re-rendered, which is what makes sense for these two, for example, not because the context changed. So why does that appear here? Well, the reason is that this value right here is an object, right? And this post provider is a child element of the app component. And so therefore, when the app component re-renders, then this post provider re-renders as well. And therefore, this object will be recreated. And so, if this object will be recreated, it means that the context value has changed. And therefore, all the components that consume that context are going to be re-rendered. All right, so that's the reason why here we see that the context has changed, because actually it did change, because this value here, so this object, did update. So the solution for that is to memoize this object. So let's create that out here. So let's do value and then use memo as we have learned earlier. And then here we need our callback function. And so this is then going to return this exact object right here. Place that here, use the value here, and then our dependency array. Now, as we save this, you will notice that this will create a few additional problems. So let's see. And so indeed, we are now missing the search query and the searched posts. So So basically these outside variables that we are using in here. So search posts and search query. So let's try that again now. So let's maybe reload, clear this. Let's start recording and stop that. And so now let's take another look. And so, well, let's actually get back the setting here because I reloaded the page. So let's do that again. And so let's see here. So this time actually we see that all of these components did re-render because their parent component has re-rendered. So we didn't actually fix the wasted render itself, but we did fix the fact that this render was caused by our context. And so if we were to memo now these components, for example, let's try out the main component, then none of these components should render anymore. Now, again, in this case, since we don't really have this app very slow, there's no need really to memo this, but all this is more to show you. Right? So make sure that you, if you want to write this code, that you import the memo function. So just like this. And then let's clean this. Go again. Let's close that. And now indeed, none of these components is re-rendered anymore. While, again, I will just go back here now to placing that here. And hopefully you're not bored by all these explanations without writing a lot of code. But this is actually a bit more theoretical than practical. But anyway, let's now see again. And now we are back to these components right here that consume the context to being re-rendered, simply because this object here was recreated. So let's place that back. And with this, it is a lot better. All right. Now, actually, I was expecting that React would ask me to also include these two functions into the dependency array right here, because it seems to me that they are also dependencies here of this object. So in case you get that, then you need to add handle add posts and this one to the dependency array. But if you do that, then you also will need to wrap these two into a use callback, because otherwise on each re-render, these functions here will be recreated again, which will then in turn also make this object to be recreated again. All right, but in this case, that didn't really happen. Let me just see what happens if I do handle add posts here. Yeah, so then I get that warning that I was just telling you about, which is that this function makes the dependencies of the useMemoHook change on every render. So move it inside that callback or wrap it in its own use callback. So this is pretty helpful here actually, but in this case, let's just remove this from here, since apparently it is not really necessary. Okay, but anyway, now let's finally also check what happens when we update the state that is actually part of the context itself. So let's clean this here. And so one example, of course, of that is right here. So let's see. And then, of course, all the components that consume this context are re-rendered. So that's the list, the search posts, and the header itself. And I think also the archive, but somehow it doesn't show up here. So here it is, again, in this ranked chart. So here we always have all of them, and then we can see that also all of these were re-rendered because context has changed. Now, I'm showing you this because if you have many components that are subscribed to a context, so that read data from a context, it will become problematic to have so many different variables inside the context value. Because as soon as you change one of these states, for example the post or the search query, then all of the components that read at least one of these 5 values will get re-rendered. And so, again, this is not ideal, and it's the reason why in the beginning I told you that we usually create one context per state. So we would have one post context and one search query context. And so in that situation, whenever we updated, for example, the search query, then all the components that consume the posts would not get re-rendered, while in this case, all of them are, because it is enough for one value here to change to re-render the entire thing. Now I'm not gonna do that right here, but again, you can basically create one context for this part and one context for this. And then what some people do is to even take it one step further. So inside the search query context, you could even create one context only for the search query and one only for the state updater function. Or if you're using a reducer, you could then create one context for the state and one context for the dispatch function. And again, I cannot really show you that here in this example because it will depend so much on your own situation. So on your own application that you're building. So these were just a few general guidelines that I hope will become useful for you in the future. It's time to shortly go back to the world-wise application in order to see whether there are any performance issues and whether there is anything that we need to optimize in terms of wasted renders. So here we are back in the world-wise application, and in case you had closed your editor before, just make sure that you start both the fake API server and the application again. All right, and then let's come here to our application. Let's just make sure to reload. And so now I want to use the profiler here as well. So just like we did previously in that other application. And let's actually make this window a bit bigger so that we can see exactly what's going to happen here. So what I want to do for now is to just record walking through the entire application to check if there are any performance bottlenecks. So to see if there is any component that might perform really badly. So let's start profiling and then let's just follow the flow of the application. So we can go to all of these different components or pages. And then of course we can log in. We can click somewhere here, go back, click on a city, maybe on the countries, maybe here, and then log out. So just experimenting everything, and then let's finish. And you see that we have a lot of renders. So we created 21 renders in total. And so let's now see if any of them was really slow. So in order to identify some really bad performing components, it's best to come here to the ranked tab. And so we see that the component that took the most time in the first render was this routes. So that took like less than 1 millisecond, which is really nothing. So remember that in the previous app, when we were experimenting with the archive, we sometimes had like 200 milliseconds or 100 milliseconds. And of course, these values are different on your computer than they are on mine. Different, but still. This is like an order of magnitude faster than what we had before. So nothing to worry here. And so let's keep going. So we just click here and then we see all the components that rendered and how fast. So let's just quickly go through them just to identify if anything was like really slow. So the most that we saw up until this point is this one, 2 milliseconds, which again is really nothing. So it seems like in this application, we have absolutely no problem with performance, which of course is very nice to see. So let's just clean this, and maybe let's just analyze one state transition here. So maybe here at this login part, just to see a bit what actually happens. So just that navigation was actually 4 state updates. So here in the flame graph, we can see that first the auth provider was re-rendered, which then made the login form and all its children re-rendered. Then next up, we saw that our router basically re-rendered. So in order to move us to the next page, so that's all of this stuff right here. And of course, you start seeing that once we add all of these components to our tree, it becomes all a bit more confusing. All right, now what do we have here? This is probably coming from the React leaflet library. So it's inside the map, and then here we have some components that are updating inside there. And so, yeah, these are related to positioning the map probably. And then finally, we have another render which was caused by our router. So that's what we can see here on the side. So as we go through here, we can always see what caused this update. So here it was again the router, and here it was the auth provider. So because we logged the user in, then the auth provider re-rendered, which then triggered all of this. Okay, and of course you can now analyze this a lot more if you feel like, and if you want to have some fun with this tool. But for now, let's go back here to our code to see what we can do. And actually not a lot, as I was saying, because everything is working really fluidly. So earlier we were optimizing our context, but even here, there's not much to do. Let's just delete this useState that we no longer need. But yeah, so again, there's not a lot to optimize here in this context. So that's because we don't have any performance issues, and also because the way that we set up our context value. So remember how earlier we decided that we want to pass in all of these functions into the context value. And so therefore, it wouldn't be practical to create one separate context for each of them, right? So that's one of the strategies that I mentioned earlier, but that's not really practical and also not necessary here. Also, there's not really a need to memorize this value right here because we don't have any component above this provider in the component tree that might re-render this one. And so there's no point in doing that. And so I think that there's actually nothing to do here, which is good. Now let's just remember that there was some issue earlier. And so we are now actually ready to fix that. So if we come back here to our city, remember that in the useEffect, we left out the getCity function. So here we see that issue where ESLint is telling us to add the getCity. But remember that this created like an infinite loop of HTTP requests to our API. But let's do that again now. So getCity. Then let's just reload here. And maybe let's come actually to the network tab, clean all of this, and then watch what happens when I click on one of these cities. And indeed, immediately we get like 1,000 requests, and it keeps going, even though the number here is not going up. But we can also see down here that every second or so, there is a new request coming in. And even here, it's of course also very visible. Now, we can even see the same in the profiler. So if we go back and then start profiling, clicking here, and then I will just leave it for a few seconds. That should be enough. And you see that we have 60 state updates only in this like 3 seconds that I waited. And so clearly there is something wrong here. And this is the only thing that we need to fix now using the tools that we learned before. But first of all, of course, we need to understand what is actually happening. So now that we have this getCity function in our dependency array, the effect will rerun each time that the getCity function gets updated, or in other words, that it gets recreated. Now, when does this function get recreated? Well, since it lives in the context, so let's open that. So this file getCity lives here, so it is created in this cities provider. But the problem is that this getCity function will update the state each time that it is executed, which will then end up in an infinite loop. So here we call the getCity function, right? And so that function will then update the state in this component. Then this component will re-render, which will then recreate this function. And as the function gets recreated, since it is here in the dependency array, then getCity will get called again, which then again will update the state, which will re-render, which will cause the effect to run over and over and over again. So that's the infinite loop that we have right here. And probably we should come back here and now take our application out of this misery. So it's been fetching like for a few minutes now, so that's a bit too much. But anyway, how do you think we can fix this? So the solution is not to remove this from the dependency array, because that is not allowed in React. Instead, what we need to do is to make this function stable. So we need it to not be recreated on each re-render. And the way we do that, as you hopefully know, is by using the useCallback hook. So let's create a new variable, which will be the new getCity function. And this will then be the result of calling useCallback. All right. Then our dependency array, which will need probably this current city. And there it is. So current city.id. And once again, just having this kind of warning here is reason enough to really always install ESLint in your projects. So without it, you will create so many bugs. It's not going to be funny, really. But anyway, this now shows you a real world use case of this hook. So of this useCallback hook right here. So this is one of these real world situations in which you will really need to reach for this tool. So that's why it's really important that you paid good attention throughout this section. And actually remember that when I first introduced these hooks, this was exactly one of the 3 use cases that I talked about. So memoizing values that are used in the dependency array of another hook in order to prevent infinite loops. So let's give it a reload here. And then let's just try it again. And if we come here to our network tab, then we see that there is no problem anymore. And also here, we are not seeing these infinite requests coming in. All right. And this is actually all that I wanted to show you in this lecture. And I can understand that it probably seems pretty intimidating, for example, to find out by yourself that this would have been the solution here. But trust me that with practice and with study, you will be able to really understand and to master all these tools. So we've talked a lot about optimizing wasted renders and overall app performance. However, probably the most important thing that we can and should optimize is the bundle size. And so let's now learn how to do that. But before we go check out the code, we first need to understand what that bundle actually is. And let's start at the very beginning. So whenever some user navigates to our application, they are basically visiting a website that is hosted on some server, right? So that's just how every single website and web application work. Now, once the user actually navigates to the app, the server will send back a huge JavaScript file to the client that is requesting it. And this file is the bundle. So the bundle is simply a JavaScript file that contains the entire code of the application. And it is called a bundle because a tool like Vite or Webpack has bundled all our development files into one huge bundle, which again contains all the application code. This means that once the code has been downloaded, the entire React application is loaded at once, which essentially turns it into a single-page application that is running entirely on the client. So whenever the URL changes in the app, the client just renders a new React component, but without loading any new files from the server, because all the JavaScript code is already there in the bundle. Now, the bundle size is of course the amount of JavaScript code that every single user needs to download in order to start using the application. So if the bundle has, for example, 500 kilobytes, then all those bytes need to be downloaded before the app even starts working. And of course, the bigger the bundle, the longer it's gonna take to download, which can become a huge problem. Therefore, bundle size is probably the most important thing that we need to optimize. And thankfully for us and for our users, it's not very hard to do. So we can just use a technique called code splitting. And code splitting basically takes the bundle and, as the name says, splits it into multiple parts. So instead of just having one huge JavaScript file, we will have multiple smaller files which can then be downloaded over time as they become necessary for the application. And this process of loading code sequentially is called lazy loading. And this really is one of the biggest performance gains that you can achieve for your users. And so let me now show you how it's done in practice. Now, there are many ways in which we can split the bundle, so in which we can lazily load our components. But the most common one is to split the bundle at the route level, or in other words, at the page level. So basically what we're going to do is to take all the components that represent a page and load each of them separately. Okay, so again, that's what most applications do, but of course we don't have to do it this way, because this feature that I'm about to tell you and to show you has really nothing to do with React Router. So any component can be lazy loaded in the way that I'm going to show you. So let's actually do that. First, let's remove these imports from here and place them here. And so now let's first identify our pages. So it's the home page, the product, the pricing, the login, then here the application itself, which is in app layout, and finally page not found. So those are our 6 pages. So that are basically these 6 right here. And so let's comment them out. And again, we will now lazy load these. So instead of writing import, let's now write just the name of the component, for example, homepage. And then we use React's lazy function. And you see here it has been successfully imported from React. Let's just place that at the top where I like it most. So this lazy function here is actually a feature that is built into React. And then Vite or Webpack, they will automatically split the bundle when they see this lazy function. All right. Now, actually thinking of these bundlers, I had the idea that I should even show you how the bundle looks like right now before we do any of this. So let's, for a second, just bring this back. So just that everything works the same way as before. And then here, I want to open up a new terminal. So again, in our project folder, and then here, let's run npm run build, which will then create our JavaScript bundle. And so we can then take this bundle and actually deploy it on a web server. So a bit later in the course, when I show you deployment, this is how we will export basically our final application for production. But anyway, we see here that we just have this one huge JavaScript bundle. So it's this almost 600 kilobytes. And so Vite even warns us here that some chunks are really large and that we should use this dynamic import. So that's exactly what we're going to do next. So for now, I just want, just for the fun of it, copy these two lines and paste them here as comments, just so that we can later compare what we get after the lazy loading. So let's clean this, make it a bit smaller, and then let's actually implement the lazy loading. And so in here, we now need a callback function, which will then call the dynamic import function, which is actually part of JavaScript. And so here, we then need again the path to the component itself. So pages/homepage. And here we actually need these to come before the dynamic imports. So just like this. And of course, we still have some errors because now all of these are not defined. So I'm just going to duplicate this a few times now and then implement all of them. So the product, we have our pricing page, again with a capital P. Then we have our login, we have the app layout, and we have finally page not found. Okay, that should be it. Let's reload this at the root. And for now, everything is working fine. But this is actually not yet the end of the story. So this is only the first part, but now we also want to display a loading spinner while we go from one page to the other one. So basically, while these pages are going to be loaded in the background. Now here I see I have a problem. So it needs to be like this. But anyway, this is now where the React's suspense API comes into play for the first time. So I've mentioned the suspense API a few times already, I believe, but now we're actually going to use it for the very first time. So I will not go really deep into what it is right now, because I will leave that for some later point. But for now, what you need to know is that suspense is a concurrent feature that is part of modern React, and that allows certain components to suspend, which basically means that it allows them to wait for something to happen. And in our case right here, basically these lazy components are going to be suspended while they're loading. And so we can then use the built-in suspense component to show a fallback, which in our case is going to be that loading indicator that I just mentioned. So let's come here into our tree, and above the routes, let's then include suspense. So making sure that component has been included from React. And then here is where we specify the fallback prop. So here this then takes a React element, which is going to be our full page spinner component. So we have here the regular spinner, and we also have a spinner full page, which is basically just a spinner, but inside one element that takes up the entire page. So spinner full page. So it looks like we're going to have to manually import that, but that's no problem. So we open the suspense, and then we need to close it here after the routes. Okay, now let's then import this spinner from spinner full page. And with this, we should be good to go. So let's just very shortly recap here before we actually try this out. So here, with this lazy loading, we will now load each of these components here as we need them, which will basically automatically split our bundle into separate chunks. And it is Vite, in our case here, that's going to take care of that. And so then, of course, there will be a time while we navigate from one page to the other where that chunk has not been downloaded yet. So for example, if we go to login, then that page has not been downloaded. And so then this entire thing, so this lazy functionality, is powered by the Suspense API. And so that will make the component basically suspended in the meantime, which will then display this loading spinner. And then once that has arrived, it will no longer be suspended, and then the content here, so the children of the suspense, is going to be displayed. So it's going to be rendered. So let's see if that works. And let's actually do some throttling here, like a slow 3G, so that we can actually see this happening. So let's click on pricing. Let's even clear our network requests. And it is working. So it's now loading that chunk. And so now that arrived. And so now the page has loaded. And you see that some additional kilobytes were transferred in the meantime. And the same thing is going to happen with the product page and with all the other pages. But of course, if I go back now, then that chunk has already been loaded before, and so it's not going to be loaded again. So it will nicely be integrated into the application that we already have. All right, so let's load up our next page, and it looks really slow, but that's just because we have this throttling here activated. So loading now the next thing. So our app layout, which is the main part of the app, and so that's why that takes a bit longer. Okay, great. And of course, now if we go back, so the second time, everything is going to work really fluidly. Beautiful. So this really is the most important feature, I would say, that we should always implement in any React application that we're building. And now to finish, let's just see the actual chunks that Vite has created for us. So npm run build. So these chunks here are not going to be exactly the same ones as in development, because in development, everything is a bit different. So this here is already optimized for production. And so we see that it all is very different. So we have lots of different chunks now here, which are then all lazy loaded. So you see that we still have a huge one right here, but probably all of them added together will be these 572 kilobytes. All right, so this 415 is not a lot less than this one, but that's already good enough. So we could now try to lazy load some other components here. So remember that it doesn't only work with routes, but I think that this is good enough. So for example, the app layout itself was apparently 156 kilobytes. And so it's really nice that we got that out of the main bundle. And notice how even the CSS is also split into multiple parts. All right, so really nice feature. And yeah, again, powered by both the bundler, so Vite or Webpack, and the lazy function provided by React, plus the import function provided by JavaScript, and then also the suspense component. So hopefully you found this easy enough that you're going to implement this in all your future applications. And with this, we have now actually finally really completed this worldwide application. So this was the last video in which we worked on this project. And so once again, congratulations for finishing this big project where we learned so many new things and covered so much ground. So I hope that you liked it and that I see you for another small project with which we will finish this section. Let's wrap up the performance optimization part of this section with a quick list of do's and don'ts. So the main message of this video is that you should not optimize prematurely. And what do I mean by that? Well, basically, don't optimize anything if there is nothing to optimize. So if your app is performing just fine, then don't just wrap all your components into a memo or all your values and callbacks into useMemo and useCallback. Also, there's no need to optimize context if it's not slow and if it doesn't have many consumers. So doing all these things can actually do more harm than good, because memoization itself can have a slight hit on performance. And so if you have 1,000 useless use memos, it can actually all add up and then even worsen the performance of your application. And that's not to mention that your code is going to become unreadable and super messy if you wrap everything into a use callback or a use memo. So please don't do that. Instead, what you should do is to find actual performance bottlenecks using the profiler tool that we learned about in this section, or even better, identify problems visually. For example, when you see a laggy and sluggish UI, because then you can focus on those real performance issues and fix them. For example, by memoizing expensive re-renders or expensive calculations. Now, when it comes to the context API, it only makes sense to optimize re-renders if a certain context has lots of consumers and if the state updates all the time, causing a significant issue. So in that case, you can try to memoize the context value, memoize all the direct child components of the provider, or set up two separate contexts. So one for the actual state value and one for updating the state. Finally, it's also super important to always implement code splitting and lazy loading for all the routes in your single page applications. Alright, and with that, you're well on your way to mastering performance optimization in React. It can be a pretty confusing subject, but also a very important one. And so it's great to see that you're still here with me. So we have talked about and used the useEffect hook a lot throughout the course. Now, useEffect is probably the most confusing part of React for beginners, which is why I decided that I still need to clarify some more things in this second part of the section and in this video. And the first thing that I want to do here is to focus in great detail on the rules and guidelines for specifying a correct dependency array. Now, the first rule that we learned when we first talked about useEffect was that every single state variable and prop that's being used in the effect must be included in the dependency array. So this one is pretty clear by now, right? However, this rule is not 100% complete because of two things. First, any context value that the component is subscribed to must also be included in the dependency array. And second, actually, we must include all so-called reactive values in the dependency array as well. But what is a reactive value? Well, a reactive value is any value that is either state, a prop, a context value, or any other value that itself references one of the reactive values. So examples of that are these two pieces of state, these two variables right here, so because they reference the duration state, and even the format duration function because it references the reactive values minutes and seconds. So basically, all values that are somehow connected to state, props, or context are reactive values. Now, going back to our dependency array, this means that every single reactive value must be included, which, again, includes any functions or variables that reference any other reactive value. And the goal of this is to avoid so-called stale closures that would otherwise occur inside the effect function. Now, these two rules that we just learned about are pretty strict and tell us exactly what must be included in the dependency array. And so this means that basically the dependencies choose themselves, right? Because if we need to include all reactive values in the list, there's not much to think about. Therefore, you should never ever ignore that ESLint rule that we've seen time and time again, warning us about missing dependencies and ensuring that our dependency arrays are correct at all times. But, of course, you want to understand why you're missing the dependencies that the linter is telling you about, and not just blindly follow the tool. And so that's what this video is for. Also, sometimes you might be in an environment where the linter is not available, and so then you really need to know what you're doing. Okay, and now the final rule is that you should not use objects or arrays as dependencies, because when you do so, it seems to work just fine, but in reality, the effect will rerun on every single render. The reason for that is that React checks if dependencies have changed between renders by simply comparing them using the triple equality operator. However, as we already know and already talked about in this section, objects in JavaScript will have a different reference each time that they are recreated. And therefore, even if the content of an object stays the same after a render, React will still see the old and the new object as different and will therefore rerun the effect. Now, if you really do need an object as a dependency, I have some solutions in the next slide. But before we go there, it's important to note that all these rules that we just talked about work in the exact same way for the other hooks that also have dependency arrays. So use memo and use callback. Okay, so as we just learned, we must include all reactive values in the list of dependencies. React calls this not lying about dependencies. However, in certain situations, including every single dependency in the array can actually cause the effect to run way too often and introduce problems. But again, the solution is not to omit one or more dependencies, because that would be lying to React. Instead, we can use one of the strategies that can make some of the dependencies unnecessary, and so then we can remove those unnecessary dependencies from the array. So, first off, when you're dealing with helper functions as dependencies, the easiest way to remove the dependency is to just move the function right into the effect. Because if the function is inside the effect, then it's no longer a dependency of the effect. However, if you can't do that, because you might need the same function in multiple places, you can try to memoize it with useCallback. Also, if the function is not a reactive value itself, so if it doesn't use any reactive values inside the code, then you can just move it entirely out of the component, because it's not really a dependency anyway. And so by doing this, the function then doesn't need to be recreated on every render. Next up, if you want to use an object as a dependency, you can try to not include the entire object, but only the properties that you actually need inside the effect. And you can do this as long as these properties are primitive values like strings or numbers. However, if for some reason that doesn't work for your specific situation, you can try one of the strategies that I mentioned for functions, as they are quite similar. And finally, we have two other strategies. First, if you find yourself in a situation where your dependency list includes multiple reactive values that are related to one another, you can try using a reducer with useReducer. So sometimes a reducer can really be like a secret weapon that makes all your dependency problems completely go away. Also, there's no need to include the setState function from useState or the dispatch function from useReducer in the dependency list, because React guarantees that these are stable between renderers. And now, to really wrap up this part about useEffect, let me give you a maybe shocking reality about effects, which is that effects should actually only be used as a last resort when no other solution really makes sense. That's the reason why React calls effects an escape hatch to step outside of React. Now, I'm telling you this because when hooks were first introduced into React, the useEffect hook was being overused a lot and also used in the wrong places. Now, I'm not really gonna go deep into this right now, but here are just the 3 biggest use cases where effects are still being overused and that you should avoid as a beginner. The first one is to use an effect to respond to a user event like a click or a keystroke. So, as we learned before, a user event should, whenever possible, be handled with an event handler function and not with an effect, even if the handler does create a side effect. Next, fetching data from an API when the component first mounts is another overused application of useEffect. Now, we did do this all the time in this course, but that's because we were still learning and building really small applications. And in fact, in smaller apps, this is completely fine. But in a more real-world application, it's best to use a professional data fetching library like React Query. And finally, effects are overused a lot to synchronize state changes with one another, which means to use useEffect to listen for a state change only to set another piece of state. And the problem with this is that it will create multiple re-renders, which can be problematic. Now, actually, we are gonna do just this in the current project, but in our case, it's just gonna be because it will highly simplify the code, as you will see. So basically, all these suggestions need to be taken with a grain of salt, as always. So really, in fact, everything is acceptable in certain situations and in certain doses. But generally speaking, instead of using an effect to set state based on another state, you should rely on derived state and event handlers. In this lecture, we're going to quickly set up yet another small project, just to demonstrate some of the things that we just talked about useEffect. And in our starter files, we actually have again the complete project already. So come here to this folder, workout timer, and then here the starter already contains the entire code. So let's just grab that, paste that here. So this one is called the workout timer. And then let's get that into our VS Code. And there we go. And once again, just like we did with our previous small project, let's start by checking how this project was created. And as we see here from this React scripts, it means that this project was again created with create React app. And so let's open up our terminal and run our start command. So if it was with Vite, then it would be npm run dev, right? However, we forgot that first we need to actually install the dependencies. So npm install, because of course, whenever you get a new project code from somewhere, it never comes with the node modules folder. So you will always have to install that yourself. And now that that's done, let's run npm start. And this always takes a lot of time loading up the project for the first time. And this time it was actually fast, but sometimes it is a bit slow. And so that's one of the advantages of using Vite. Okay. Now the first thing that I usually like to do in order to get myself familiar with a new project is to just check out the component tree with this dev tool right here. So we see that all we have is this app component, the toggle sounds component up there, and this calculator. All right. And then, of course, we need to go check out the code as well. And so that is actually my challenge for you in this lecture. So just like before in that blog application, I want you to get familiar with this small code base right here and really understand how this application works and what it does. And then on top of that, I want you to use our profiler tool here on your own in order to identify a potential performance problem that you can then fix. So again, try to find a performance issue in this application according to what we learned in this section. Now, this performance issue is not really affecting this application visually, but as an example, we can still fix that here so that you can practice the tools that we have learned in this section. So in particular, the memo, use callback, and use memo hooks. All right. So take a few minutes now, analyze the components that we have, and then try to find and optimize that small problem. And I see you back here once you're finished. Okay, so did you find that small performance issue that I was talking about? Well, to show you, all we have to do is to just start profiling, then wait a few seconds without even clicking anywhere here, and then we just stop it. And so what we see then immediately is that we had 8 renders where in each of them all of the components got re-rendered. So for some reason the toggle is only appearing in this one, but this component is also being re-rendered every single time. And so the reason for these 8 re-renders is, as you might have noticed here, that this small clock makes this app component re-render every single second. And so that is coming here from this use effect. So here we are setting a timer that runs once a second and which sets the time state to the current time. And so this means that this component, so the app component, is re-rendered every single second. And as a consequence, both its child components will be re-rendered as well. So this was the issue that I wanted you to find and then to fix. And so let's now fix it. And again, just note that maybe in a real world application, we would not have to fix this unless one of these child components are of course really slow and heavy components. But anyway, here we are just learning. So again, we want to practice those tools. And so let's now open up the calculator and the toggle sounds components. All right. So what can we do about this performance issue? Well, if it is some children components that are re-rendering just because the parent component is re-rendering, then the solution is to memoize those components, right? Now, remember how earlier we memoized a component by basically creating a new variable here, like toggle sounds, and then we would wrap this function into memo. However, since here we are actually exporting these components, it's a lot easier and nicer to just memoize down here. So let me show you what I mean by that. So we can just export basically the result of memoizing this component. And so this, again, is a lot better than creating a new separate variable here, which makes the code look a little bit weird. Okay, so let's do the same thing here. So memo, and there we go. Now, do you think, or did you even experience during the challenge, that this already fixes the problem? Well, let's see. So waiting again for a few seconds. And, well, not really. So the calculator is indeed still being re-rendered. Let's see about the sound toggle. So that one is never appearing. And, here in this flame graph, we can see that this one is no longer re-rendering. But again, the calculator component is always re-rendering. So let's see what we can do. So remember that the memo function only works if the props that are being passed are the same between renders. So here in this toggle sounds component, that is apparently the case. So allow sound is just a primitive value. So it's just a Boolean. And so therefore that doesn't change across renders. And then the second prop is this setAllowSound function. Now remember that the state setter function from useState is actually stable. So React guarantees that it doesn't change between renders. And so this means that these two props do not change between renders. And so therefore the toggle sounds component does not re-render each time that the app re-renders. So we successfully memoed or memoized this one. Now about the calculator component, the allow sounds of course also stays stable, but now the other prop is the workouts object, or actually the array. And so here is where we have the problem. So since this is an array, which is essentially just a JavaScript object, this array gets recreated on every single render. And so therefore we now need to memoize this array in order for the memoizing of the component to work. So let's do that. And it is useMemo because it's just a value and not a callback function. So let's wrap that into useMemo. And remember how here we need to pass in a function which React will then call on the initial render. And here, due to the nature of array functions in JavaScript, we actually need to create a function body and then return this array from there. So close that here, but then we are missing the dependency array. Okay, well, apparently there's some other problem here. Like this. All right, give it a save. And now here we already got the warning, but we don't want to read the warning. So after the last lecture, we want to actually now understand what is missing here in this dependency array. So remember how we just learned that the dependency array needs to include all reactive values that are used inside the function, so inside the hook. And we talked about useEffect in the previous lecture, but the same thing applies to useCallback and useMemo. So all reactive values in this component are of course these two state variables, but also this part of day variable because it depends on the time state. So it is using a reactive value, and therefore this is also a reactive value. And since we are using that value inside this array, this means that we now need to include it into the dependency array. So part of day, and now ESLint is no longer complaining. All right, and so this should actually fix it. So let's try that again. That should be enough, and nice. So now our calculator is also memoized. So that works, and yeah, that was basically the goal of this lecture. Now there's just another small thing that we can do, which is about this function here. So this function that is inside the component body right here doesn't actually use any reactive value, right? And so there's no need to recreate this function on every render. And so let's cut that and place it out here. So another very small optimization, but yeah, we don't need to waste any resources only to recreate this function when we don't need to. And with this, we actually wrap up this video. And so next up, we will start working a bit on changing this application. So it's already working just fine for the most part, but for example, these buttons here don't do anything. And so that's what we're going to change next. Let's now implement the missing functionality of this application, which is to actually make these buttons here work in order to manually adjust the duration. So right now, the duration here adjusts each time that we set one of these states right here. So hopefully you analyzed that when you first checked out the code. So notice how we have 4 pieces of state here, one for the number, so this one, then for the sets, for the speed, and for the duration of the length. And so then the duration here is a derived state, which is on every render calculated from these 4 state variables right here. And so that's what we then get here. So of course, as soon as we update one of these state variables, the component re-renders, and then the duration gets recalculated and displayed here. So that's just very common stuff that we have been doing all the time. But now, again, we actually want to make these buttons work. So we want the duration to update as a result of clicking these buttons. And so that means that the duration now needs to be a new piece of state. So let's do that. So let's comment out this one and place the duration in state. So duration and set duration is use state, and let's start at 0. So we can not simply place this formula right here because it would only be called on the initial render. Remember that? And so that's not what we want. Of course, we will want to calculate this duration each time that we click on one of these buttons, but also each time that one of these state variables here changes. So just like it was working before with this derived state. And so now we need a way of getting this functionality back. So basically of updating the duration state each time one of these state variables here updates. Now there are 2 ways in which we could do this. So we could update the duration each time that we update one of these in the event handler function. So basically we have, of course, one event handler for each of them. For example, here is the one for the number, here is the one for the number of sets, so for this one right here, and then these are the ones down here. So one event handler function for each change event on each of these input elements. So as I was saying, we could now in each of these event handlers not only update the state that it is about, but also the duration state. So for example, here, besides doing that, we could then also set duration and then copy that formula over here. And let's actually just do this here as an example. So this is not the solution that we're going for, but I just want to exemplify this. So now here, of course, we cannot use the break here because it is still stale. So the update only actually happens after the render. So as we have talked about many times before. So here we would even have to use e.target.value. And so let's see. And so that would actually work, right? But we would then have to do this in every single event handler. So repeating all this code all over the place. So instead of doing this, we will now again use the useEffect hook to basically synchronize these states with one another. So just fixing this here seems a bit complicated, All right. So what we're going to do now, as I just said, is to use the useEffect hook to keep this duration state here in sync with all these other state variables. Now, notice how I said earlier in that long lecture about the useEffect hook that this is exactly what we usually should not do. However, I think that in this situation, this is a perfectly fine use case for the useEffect hook, because there are so many state variables here involved that it just becomes very impractical and even unreadable and confusing to do it in the way that I just demonstrated you. And so, again, we should instead use an effect in this situation. Okay. And the dependency array, we can already write it ourselves so that we understand why we actually need this effect. So here we will want to set the duration whenever the number changes, or when the sets change, or when the speed changes, or when the duration of the break changes. All right, and now here we then need that actual formula. So exactly this one right here. And so then we will be back to the application working in the exact same way as before. So everything works here. And so now with this in place, we can implement these two buttons, which of course still don't work. But we first had to do all of this here so that we could now then also set the duration state when we click on those buttons. So let's actually write separate event handler functions in this case. So function handle inc, let's say. And so here we get the current duration, and we want to return the duration plus 1. So at least for now. So let's find the button here. Yeah, so right here, let's now replace this dummy function with handle inc. And so, yeah, that works. Nice. Now let me just show you something. So I'm trying to find a situation where here we have half a minute. And so here is one of these situations where we have half a minute. And so in this case, when we click on this button, we actually want to round it to the next value. So the next entire value. So that would be 83 in this situation and not 83 in 30 seconds. So what we can do is first round that down with math.floor. And yeah, so now that works. Okay, and now let's also create handle decrement. So handle dec. And here we're going to do the opposite. So we will first round up the current duration, and then we will subtract 1. And so now this will first round it up to 80, and then from there we go down to 79. Now, of course, we need to wire this up. So place that function here. So handle dec. And so again, it will now go down to 79. Now, the problem is that if this is really slow, or really low, actually, then, of course, we go to negative values. So let's fix that. And so here, let's use a ternary. So if the duration is still greater than 1, then do this, but otherwise, then the next duration will be 0. All right. And 1 minute and 0, and we can't go below that. Nice. So with this, we implemented what we set out to do. So these buttons now work, and again, in order to do that, we needed to transform this duration here into a state variable. And so then to update that state variable in an easy way, we created this effect which listens for the state change in any one of these 4 state variables. And if that happens, it will then calculate our new duration. And so here we have the classic example of using an effect to update state based on another state update, which again is not always desirable and it's not always the best solution. But here I think it is perfectly fine, because otherwise we would have to spread this logic here into 4 different event handler functions, which wouldn't be really nice. Now let me actually show you the downside here. So using the profiler, so let's start, and then I will just adjust the state once. So 1 state update, right? Well, we now get all these state updates because of the timer they're updating. So let's maybe turn that off actually just for a minute. So let's do this. Let's do this again. So only updating once, which we would think only gives us 1 render. But actually we do have 2 renders. So the calculator is rendered and then again. And so this is exactly the problem of the useEffect hook to update states. So right here. So basically this first state update is this number of sets updating, which will then trigger this effect here. But the effect only runs after the render has already happened. And so then when we set the state here again, we get a second render. So React is not able to batch these 2 renders in one, simply because, again, the effect actually runs way after the render has already happened. And so just be aware of that issue whenever you do something like this. So whenever you can, again, avoid this, but when you have so many state variables here that influence the value of another state, then you can do this. In this video, we're gonna play a sound whenever the duration state changes. And this will bring up all kinds of interesting issues that we are gonna solve using the strategies that we have learned in the advanced useEffect lecture earlier. And I already created this function here to play a certain sound. And I think it's pretty interesting. So what we have to do is to first import a sound file. So like this one that is here in the source folder. So we import that, then store it into some variable, and then we can use that using the audio API from the browser. So this is here just a browser feature. So this then creates a new audio, which I just called sound, and then on that we can call the play method. All right, and so now let's use this function in order to play this sound each time that the duration updates. So where does that actually happen? So where does the duration update? Well, easy enough, here in these 2 handler functions and in this effect. And so let's just play, or actually call, that function in all those places. So here and here. So in the 2 event handlers, and let's already test if this works. And yeah, I can very clearly hear that sound in my headphones. So it's not in the video because of my headphones, but you should probably also hear it. Now, if you do not want that sound, maybe because you need to be in silence or something, then you have this icon right here. So this is coming from the toggle sounds component. And so when you click here, it will set the allow sound state to false. And so then in this case, the sound is not played. So then it goes just back to normal. Okay, but here, for the sake of this exercise, let's leave it on and see that it works just fine. Okay, but of course, as we change the duration here, that will not yet play the sound. And so let's also place that here. Okay, but now this placeSound is actually a reactive value because it uses another reactive value. So this allows sound prop. So it is actually a prop, but we see that it is a prop that is actually state. So that allows sound prop is a state variable, and therefore it is a reactive value. And so this function is then also a reactive value, and then we need to place it right here. So play sound like this. Now here since we are using not a normal function declaration, but a function expression, we need to place it here before. And so now it is back to working. Now notice how here in the console we get these issues, which tells us that a sound cannot be played before the user interacts with the document. So the user first needs to click or really do something here before the first sound can be played. But let's just ignore this issue here in the situation. Okay, so we placed our placeSound function here in the dependency array in order not to lie to React about the dependencies. But watch the problem that this actually creates. So as I try to update the state here now, as I click here, nothing really happens. I mean, we hear the sound like playing twice, and very shortly it goes up and then goes down again. So you see this flicker here. And so that is a big problem. The same thing probably appears here. Now here it actually works fine, but not when we click on these buttons. So let's find out what the problem here is. So each time that we click here on this button, it will set the duration and it will play the sound, right? Now updating the state will of course re-render the component, which will recreate this function here. So React will see a brand new function. And since this function is part of the dependency array of this effect, it will then run this effect as well. And so that's where the duration is then set again, but using the current values, which actually haven't changed. So when we click here, none of these 4 values changes. And so when the duration is then set here for the second time, it will use these values again, which will make it so that the duration immediately goes back. And so that's why we see that flashing. So for a fraction of a second, it will go to 53, but then immediately it will go back. So, saw that here? So that is the reason why this is happening. And also why we kind of hear the sound twice. So we hear it here, and we then hear it again from this effect. So what can we do? Well, as we learned in that lecture about the strategies on how to deal with helper functions, which this clearly is, there is a few things that we can do. So the best strategy is always to move a function like this out of the component. However, that doesn't work because this function is of course a reactive value that depends on this prop. And so we cannot move it outside. Then the other strategy would be to take the function and move it into the useEffect. So right into here. But then the problem with that would be that we could no longer use it out here. And so this is the situation where we need that function in multiple places. And so then what we have to do is to memoize the function. And so then the function will not be recreated between these renders. So let's do that. Use callback. And then here in the dependency array, what do you think we will need to place there? Well, we will need for sure this allow sound variable, because this is a reactive value. So a value that can change over time. But what about this click sound? Well, this one not really. So this is never going to change, and React knows that. And therefore, if we now save this, we get no warnings. So meaning that our dependency array is complete. And so if we try this now again, then it is actually back to working. And it does work everywhere. Nice. So yet another use case of the use callback hook. Now, one very interesting consequence is that now as we click on this button, so on this icon right here, it will actually play a sound. So did you hear that? Not when we turn it off, but when we turn it back on, it will play a sound. So that's a bit strange, right? So why is that happening? Well, notice how here allow sound is in the dependency array of use callback, which means that this function here actually does get recreated each time that allow sound changes. Therefore, when we toggle this icon here, we get a new function, which then in turn will make this effect here run again. And so that's where then the sound is played. All right, so this can quickly become confusing when you use all these use callbacks and use effects in your code. And let's see how this actually becomes even worse. Because let me now update the state here a little bit, and then watch what happens when I click here. So you saw that it basically reset our state. So very strange, very confusing probably, but again, it is actually for the exact same reason that earlier we heard the sound when we click here. So the reason for that is, once again, that whenever we click on that icon, the allow sound state changes. And so then the function is recreated. So then on that update, React sees a new function, and since that function is here in the dependency array, it will run this effect again. And so this effect will run with the current values of these 4 pieces of state. And so it will recalculate the duration based on that, basically ignoring that earlier we had manually changed the duration with these buttons. Okay, so of course I did all this on purpose. So I created this kind of sophisticated example to show you all these consequences that these hooks can have in our code, just so I could show you the thought process behind analyzing what happens here, so that you can in the future think about this stuff on your own. Okay, so I think that this is really, really important and will make you a better React developer for sure. Now, the solution for this problem is to do something completely different. So instead of using use callback here, and instead of playing the sound here and here, we can do something entirely different. So let's think about this. When do we actually want the sound to play? We want it to play whenever the duration changes, right? So that's why we placed this function in these 3 places. However, as I just said, there is a better way of doing that, and one that is way more clear and more intentional, which is to simply synchronize this side effect of playing the sound with the duration state. So instead of all this that we just did, is to create a new separate effect which will be responsible for playing the sound. So basically for keeping the sound synchronized with the duration state. And now, thanks to this, so now that we no longer need this function right here, we can take the function, well, let me comment it out and leave it here for you, but we can now take this function and uncomment it and remove the use callback, of course. And well, and what's this? It's function. No, not whatever I had there earlier. So anyway, now we can remove play sound from all of here remove this, of course, from the dependency array, which is what we wanted all along, and then remove it from here as well. So take all of that away. And so now here is where we want to call that function. And so again, this time we were able to finally move the helper function into the effect. And so this is also a great demonstration that we should in fact have one effect for each side effect that we want to have. Or in other words, this effect here should only be responsible for setting the duration, not for setting the duration and playing a sound. So instead, we just create one effect that is responsible for playing the sound. And we do that whenever the duration changes. So here we actually voluntarily declared this duration variable in the dependency array, even though we are not using it anywhere here. So this is simply to tell the effect that we want it to run whenever the duration changes. And now here we are then missing this reactive value again. So let's place that here. And with this, everything should be well. So let's just reload this. And now it works here. It works here. So both the sound and the functionality. And when I click here, it will not reset anything. So it's going to work just as expected. And also, just like before, when I now click here, the sound will play. And so the reason for that is this allow sound variable right here in the dependency array. So causing this play sound function to play, which even makes sense in this situation. So when we turn it off, we hear no sound. And then just as an indication that it worked, we immediately get that sound feedback. Nice. So this was quite a journey where we explored a little bit deeper how this dependency array works and how these different hooks interact with one another. So that thought process that I showed you, I think is pretty important. And so I hope that you liked this lecture. So this deep dive into useEffect and into all the techniques that we can use together with it. To finish this section, let's now revisit the topic of stale closures so that we can dive a little bit deeper into this important topic. So when we first learned about useEffect, maybe you have wondered why useEffect actually needs the dependency array in order to know when it should execute the effect. So why can't the effect not simply rerun automatically whenever it should? So to analyze this issue, we need to talk about closures. So in JavaScript, a closure is basically the fact that a function captures all the variables from its lexical scope, so from the place that it was defined at the time that the function was created. So again, whenever a function is created, it closes over the effects of that lexical environment at the time. And so it will always have access to the variables from the place where it was defined. Now in React, hooks actually rely heavily on this concept of JavaScript closures. And that is especially true for useEffect. So that's where we mostly see this happening. And since this is such a great confusion for many React developers, I wanted to take some time here to now talk about closures and stale closures in the useEffect hook so that you understand even better how all of this works. So this is the type of advanced lecture that you probably are not going to find in most other React courses. So let's just write a very simple effect here. So just one more effect. And actually what we're doing now is nothing new really. All I'm going to do is to summarize basically what we have been seeing throughout this course until this point. But anyway, in this function, all that I want to do is to change the document title to a string which contains the number of exercises. So this title should be your, and then here the number of workouts or of exercises in the workout. So your, for example, 5 exercise workout. So let's give this a save. And then indeed we get your 9 exercise workout, which is exactly what we have here. So as I mentioned at the beginning of this lecture, this function right here, so by the time that this function was first created, it closed over the variable environment that was present at the time that this function was created. So that was in the initial render. So a closure has been created here at the time that this first render was created, and it closed over the props and the state in the case of React. And in React, we can actually also call this current state and the current props a snapshot. And so any function that was created at the initial render and then not recreated still has access to that initial snapshot of state and props. And so that's exactly what we have right here. So this function is created at the beginning, but then never again. And so therefore, here we now have a closure with that initial snapshot. And with the dependency array that we have right now, which is basically here the empty dependency array as this default, this function will actually never be recreated again. And so it will never get access to the current new snapshot. For example, as we change some of these state variables, for example, this number here. So if we change the number of exercises, as we would expect, it did not change that up here in the title. And in fact, we can prove that with any other state variable. So for example, the duration state itself, or these sets. So if we change anything here now, then you see that this log here happened once at the beginning, but then as we keep changing these values, this effect will not be executed and we don't get the fresh values inside this function here. So all of this is to say that what was created here is what we call a stale closure. So it's an outdated closure because the function has captured the values from a time where the number was still something else. So where it was still 9. Now in the meantime here, it actually re-rendered because I changed some code. But again, if I change this to something else, here it is still showing the outdated value. So the value from the closure. So essentially, the effect function can not see all of these variables here unless we specify them in the dependency array. And so let's now do that. So let's specify at least the number variable right here. And so basically specifying a dependency array is a bit like telling the useEffect hook something like, hey, I know that you cannot see the current values in the current render, but I promise that you only need to rerun this effect whenever number here actually changes, and everything else does not matter to you. Right? And so if we change this now, let's say to 9, then React understands that this number state here is actually important for this effect, and so then it will re-execute it. And by that time, the function can then close over, so it can then capture the new snapshot. So basically what the duration, the set, and the number are at the time that this function is executed again. So let me now clear this here, and I will now change the sets to 5 and the duration to 120, let's say. Then let's change that here. And then we see that our effect is again referencing an old value. So the duration here is still the duration from before. And so again, this is here a stale value now inside the stale closure. So that's why we really need to define all of these values in the dependency array. So again, if we change this here to something, so right now that duration is 42, And so now when we change the number of exercises, our effect function will capture the duration, the sets, and the number at this exact time. So remember, that is 42. And so indeed, now it again tells us that the duration is 42, even though it has already updated to 30. And so we would, of course, then have to update the duration here as well. So adding it here. And since we're here, let's add all of them. And so then it should really work. So let's say now we are at 21. And if we change this now to 9, then you see that it does get the newest value. And so now the stale closure has completely been eliminated. So at this point, our function here will always get access to the latest snapshot that it is interested in. Now, of course, if any of the other state variables out here change, so one that is not in the array, then this function will still not get access to them. But it also doesn't need to, and it doesn't want to. And so that's then not a stale closure. So the stale closure only happens if this function is still referencing some old values that are outdated by the time that this function is running. Okay, and so this is all that I had to show you in this lecture. So this was more talking than anything else, but that was also exactly my goal here. So if you want, you can play around a bit more with this, maybe in this other effect or creating some more effects, because this is really the most important thing if you really want to nail this down. Okay, let's just clean up the code here before we finish this section completely. Here we can just keep that. And then let's also get our timer back. So now that's updating right here every second again. Okay, and that does it for this section. Please make sure to review all the parts that you found most confusing. And then once you're done with that, once again, I meet you in yet another new section. So hopefully I see you there very soon.